In this post, I would like to talk about the lateral stiffness frequency and main time period of an existing building that have a weak stiffness and can be shaken by a man. Here is the gap between two existing buildings. We install a displacement gauge here and try to shake the building just by body movement of a man. This is a 3-story concrete building under construction. This building, the left one in the picture, has a concrete moment-resistant frame with 3 floors, 9 columns, and total height of 11.12 meter. The section of all columns and beams are a square with the dimensions that are shown in this table. All floors are block on joist with about 50 mm thickness of concrete slab on it, which means they are rigid diaphragm. This building has an unordinary problem. It will be shaken when you walk on it. The building in the right side of the picture does not such a problem and completely stiff and stable. To find out what is the problem, we conducted a simple dynamic test which can be called a forced vibration test. We installed an accelerometer that can record acceleration of building and a displacement indicator gauge in the gap between two buildings that can show lateral relative displacement of buildings. Besides, we apply the lateral load by the body movement of a man here. The lateral load will be generated by the body movement of a person is almost the harmonic load. The maximum measurement of dial indicator gauge is 10 mm, about 5 mm in each direction. The accelerometer is a wireless 3-axis accelerometer that can record acceleration in X, Y, and Z direction. Each measuring increments around the face is 100 mm, and each complete cycle shows 1 mm. Each measuring increments in the small circle of gauge is 1 mm, and the maximum measurement is 10 mm. This video shows how we apply the lateral load to the building. We are on the 3rd story and try to shake the building just by the body movement of a man. The applied load is actually a simple harmonic force with an excitation frequency close to main frequency of the building. How do we find this excitation frequency? It is based on the lateral movement of the building, and we synchronize the frequency movement of our body based on building response to find the closest excitation frequency to building response frequency. In this frequency, we will have the maximum building response. The acceleration is recording the response acceleration of the building, and displacement gauge shows the relative lateral displacement between two buildings. The lateral relative displacement of the building is more than 1 mm in each direction. When we stop applying the load, building vibration into a free vibration mode, and gradually the amount of lateral displacement will damp to 0. I can also push the building by my foot from another building and make a free vibration movement. The above record is response acceleration record before baseline correction and filtering. As you can see, the acceleration record is started from a non-zero value, which is about 0.03 g. This initial value can cause enormous error during integration process to obtain velocity, especially displacement. Also, on-pass filtering will filter out the frequency noise in the record. The signal processing of record was performed by Sysma Signal software. The above curve is the response acceleration record in time domain, and below curves are a spectrum of acceleration in frequency domain. We can find the frequency of oscillation from acceleration record. F actually is equal to number of oscillation divided by time. In our case, we have 10 oscillation and its time is about 5.8 seconds. Therefore, our frequency for this acceleration is 1.72 hertz. And the period is inverse of f of frequency, which will be 0.58 seconds. Also, the domain of our acceleration is about 0.015 g, and actually it is equal to 147 millimeter per square second. We can obtain these values directly from the software, which are similar with our calculations. The main period of structure based on MBCC 2020 is about 0.46 seconds. Remember, the main time period of the code is based on final construction phase, which the infill walls have been constructed and all mass due to non-structural components also have been applied. But a large amount of time period of this building in comparison to time period of code shows degradation in stiffness of structure. That is our next session topic.